Hello. So in this video, we're going to talk about precision versus accuracies. This should be a quick little video by popular request. So what do we mean when we say these things? So precision is sort of the specificity, or the level of being specific. I'm being sort of vague here. For those that have taken sort of chemistry or physics, precision is about the sort of sig figs thing. So accuracy, on the other hand, is sort of correctness. Again, these are sort of vague words, but I feel like I think this is easier to see with an example. So let's think about pi, which is sort of historically a good thing to use here, because pi historically has been sort of one has tried to calculate this in a number of ways that were precise and not accurate, accurate and not precise, and some combination therein. So you could say, or you could claim, that pi is equal to, and to be clear, it's not, what I'm about to write is not true, but you could claim pi is equal to 3.2186243. Right, so I could claim this. This is not true, right? Pi is actually 3.1415, etc. Now, what I've done here is I've given a lot of significant figures, or a way of thinking of it is I've given a lot of decimal places worth of sort of information. So this is very precise. However, this is not very accurate. So in some sense, I've given you a lot of specific information. I've given you a lot of decimal digits in my claim. I was very specific about the value I think pi is. I'm just wrong, right? So it's not accurate, but it is precise. Now, on the other hand, I could claim that pi is 3. Now, if I'm rounding to the nearest whole number, I guess that might be true, right? But it's certainly not equal. It's just that would be the closest whole number. So this is accurate. So accurate in the sense that what I've written isn't so much wrong as it's really imprecise. It's not specific. I haven't given you very many digits of accuracy, which, not to be confused with actual accuracy, which is why I'm talking about this, because it's a confusing difference. So it's accurate, but not precise. And so in particular, if we were looking at sort of a graph, which is where this sort of came up, right? Something like this, right? This was our profits or whatever. And I wanted to get some information about that point, I might be able to get something, if this graph is accurate, I could get some low precision. This is often referred to in the sort of industry out in the real world as the resolution of accuracy, or the resolution of precision. So I could get something and say, like, this is, about, so if my input is sort of days that have happened, this is maybe like 293, right? I'm going to write a little tilde there because it's roughly that number. But that's exactly the point, is it's roughly. This might be accurate. I'm not really sure without knowing the accuracy of the thing, but let's pretend for a moment this could be accurate, but this is not very precise. Because maybe it's 293.27648928 or something, right? Now there's an argument to be made, like how precise, do you really need it to be, right? How many digits do you actually need? So maybe this is fine for what you're after, right? Maybe this is a high enough resolution for your precision that that is okay. But if we want to get a high resolution, if we want to be very precise, that's where we tend to need the analytic methods, the actual algebra, as opposed to saying pi is basically 3, which is not true at all. And then that, that piece is sort of the accurate but not precise. That's the sort of graph equivalent, as opposed to trying to get something with more digits that might be more accurate, right? If you're building a building, or if you're building a bridge or something, you want to make sure that the person is using enough precision that the thing doesn't collapse on you. Okay, so that's pretty much, that's that, precision versus accuracy. So accuracy means that you're sort of right insofar as much as you've supplied, whereas precision is supplying sort of more digits, more accurate, sort of more specific information. Excuse me. I keep saying accurate for some reason, but all right, so that's that.